Okay, so we talked about all of these pieces parts, but we didn't actually look at this parabola and then write down all the pieces of information. And this is something that you're going to have to do on both your practice and on your next test, and maybe a quiz or two in between. So you're going to be given a parabola and you're going to be asked to identify all of these characteristics. So the axis of symmetry is a line. It is a line, and for most parabolas, the kind that open up, the kind that open up, and the kind that open down have a vertical axis of symmetry. There are a few parabolas that are sideways, and we don't study these until we do conic sections, and conic sections happen in pre-cal or maybe college algebra. But we do have parabolas that open side to side. Those are not functions. Like I said, they're conic sections, but they would have an axis of symmetry that's a horizontal line. So for the most part, all of the ones that we're going to be working with is this vertical line. And remember, vertical lines are the ones that have an easy equation. The easy equation is that it's crossing the x-axis, so we know it's an x equals line. So we're going to put, it's always going to be x equals because it's crossing the x-axis. Where is it crossing the x-axis? It's crossing the x-axis right there at 1. So the equation for the axis of symmetry is 1. The equation for the axis of symmetry will also always tell us what our h is. So up here, if I can get it to scroll up, on axis of symmetry, you might want to write that it's always going to be the equation x equals h, because the h is going to be where our vertex is, and since the axis of symmetry always passes through the vertex, the x value of that vertex will always be the axis of symmetry. So that's a formula that you can kind of memorize. The vertex then is just going to be something that you look at and calculate. This one is located at +1, and then we go down 1, 2, 3, 4. So that vertex is located at +1 and then -4. That then is going to help us with the range. This one's opening up, so this vertex right here is where the range starts, and since the vertex is at -4, that means our range is going to start at -4. So we're going to put the -4 down here, and this one's going to +infinity. We should always include the -4 because it's a solid dot, it's a solid graph right there. The vertex right here is a solid dot. It's a solid graph through that vertex, so that's why we put a bracket in front of the 4. And then, of course, the inequality gets a parentheses. Okay, the y-intercept, we just simply look and see where it crosses the y-axis. That looks like it's crossing the y-axis at -1, -2, -3. So it's an ordered pair, remember, so it's at 0, -3. The mirror image is also going to be a point, and the mirror image is also down at -3. It is 1 unit away from the axis of symmetry. The axis of symmetry is at 1, so the mirror image is going to be at 2, -3. This is for graphing purposes. You'll run into that when we're working with equations rather than graphs. The next video will be working with equations, looking at those instead of graphs. I ask right here for the roots. Do you remember what roots are? It says right up here that roots are the same thing as x-intercepts. So it says here x-intercept solutions. You might want to add roots and zeros. Roots and zeros. Those are all words that they might use to ask you about the x-intercepts. So the x-intercepts is happening at -1, 0, and at 1, 2, 3, 0. You'll notice that you can also average these two x-intercepts, average them together, and the average of those is going to always be where your axis of symmetry is. So what do we do when we average two numbers? We add them together and divide by 2. So you add 3 and -1 together, you get 2. Divide it by 2, you get 1, which is exactly where it is. Remember, the domain is like a trick question because it's always going to be all real numbers. And in behavior, this one is on the left. My graph is going up. And this one is on the right. My graph is also going up. So on the left, I wrote negative infinity, the graph is going up, and on the right, the graph is going up. My intervals of increase and decrease, my intervals of increase and decrease, so intervals, so I'm going to be writing, an interval, so I'm using interval notation. So, and we're going to, the vertex right here, the x value or the h value of the vertex is always going to be where your interval changes, because you notice right here on the yellow side right here we're decreasing, and on this side right here we're increasing. So intervals of increase and decrease. So I'm going to write the increase first because it asked me for increase first. So it's increasing starting at 1, the h value starting at 1, and then it's going to go to infinity because it's the rest of that graph, that other side of that graph. It starts at 1. We don't include it because what's actually happening right there at 1, that's the turning point. So at 1, it's neither increasing or decreasing, it's where it's turning. The 1 right here is neither where it's increasing or where it's decreasing, it's where it's changing from increasing to decreasing. So we never, ever, ever want to include this. This is the interval of increase. I'm starting at 1 and then I'm going up to infinity forever. I'm starting right here at negative infinity because I'm talking about on the left side. I'm starting at negative infinity and I'm going to be going down, 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 down. Most people, the problem that they make right here is they try to tell me y values instead of x values. So you might want to write that down up here, intervals of increase and decrease. H is where it changes. And H is where it changes. So H is what's going to be in the interval. And it's either going to be negative infinity to H, or it's going to be h to positive infinity. That's what it's going to be every time. Now what changes is whether this one is increasing or whether this one is decreasing. That's the only thing that changes, but these are going to be your two answers. You just have to get it in the right order. I ask for increasing / decreasing, so this is the increasing one and this is the decreasing one right here. Sometimes I may separate it and I just ask you for the increasing one, or I just ask you for the decreasing one. So H is where it changes. Always give me the X value because that's what I'm asking for. What are the X values where the graph is decreasing? What are the X values where the where the graph is increasing, decreasing and increasing? So it's always going to be H and infinity and negative infinity to H. It's just which one of these is it called? Is it going to be increasing or decreasing on that interval?